Well, January 2025, let me tell you, it was quite the month for weather, wasn't it? On the one hand, the U.S. had its coldest January in, gosh, over 3 decades. But get this, globally, it was the hottest January ever recorded.
It's almost like Earth decided to throw us a curveball, huh?
It really does. I mean, you have these two extremes happening at the same time. So what's going on?
It really shows how complex this whole climate change situation is, you know? You'd think a La Nina year, which usually makes things cooler, would make a bigger difference, but this time, not so much.
So let's dive into this a little bit. First, that deep freeze in the U.S. How cold are we talking here?
So, in the US, the average temperature for January 2025 was way below what it normal is, like for the whole 20th century. Actually, it was the coldest January since, get this, 1988. And over a dozen cities, mostly in the southeast, had some record-breaking lows. We're talking top 10 coldest Januaries ever for them.
Wow, especially for the Southeast, that's pretty unusual. What was behind this cold snap? What kept it going for so long?
So the main thing was this stubborn weather pattern called a Greenland block. Basically, it's like a wall of high pressure just sitting over Greenland, and that forces the really cold Arctic air down south into the US. And to make things worse, there was another blocking pattern from like Western Canada all the way to the Eastern Pacific Ocean. So it was like this double whammy trapping all that cold air.
So basically, these blocking patterns just kind of shut the door on the U.S. and wouldn't let that cold air out.
Right, exactly.
And wasn't there a bunch of winter storms in January, too? Did those have anything to do with this cold air?
Oh, absolutely. It's like this frigid air mass was setting the stage for these storms. We had four major ones hit the U.S. in just 18 days. Cora and Enzo, those were the big ones, especially for people down on the Gulf Coast. They don't usually get hit with such intense winter weather. Enzo especially was one for the record books, just really powerful and disruptive.
Yeah, those storms were no joke. But here's the thing. While the U.S. was freezing its, off, the rest of the world was baking in record-breaking heat. Kind of a head-scratcher, right?
You're telling me, I mean, it's a crazy contrast. The U.S. was shivering, and meanwhile, the whole planet was experiencing this crazy warmth like never before. Actually, it broke the record for the hottest January ever, and that record was just set last year.
Wow, talk about a swing in temperature. So where exactly were these global hotspots? Where was this warmth most intense?
Well, believe it or not, Alaska, land of ice and snow, had its eighth warmest January on record. Big parts of Canada and Russia were also unusually warm. And down in Australia, they had their second hottest January in, get this, 115 years.
Wow. It really seems like this heat wave hit every corner of the globe. What about the oceans? Were they unusually warm too?
You bet they were. Huge stretches of the Atlantic, Indian, Pacific, you name it, they were all record warm for January. And that widespread ocean warming is a big deal when you're trying to understand why the whole planet is getting hotter.
So basically, the Earth decided to crank up the heat everywhere except to the U.S., huh? Why would that happen, especially during a La Nina year when things should have been cooler?
That's the question that has scientists puzzled. And they're looking at this surprising possibility, and that is, get this, less cloud cover. I know, it sounds kind of strange, right? But it turns out the amount and type of clouds can really mess with global temperatures.
Wait, hold on. Fewer clouds would make the planet warmer. Don't they usually block sunlight and keep things cooler?
Yeah, some types of clouds do, like those low-hanging ones, they act like mirrors, reflecting sunlight back into space. That helps cool things down. But other types, like those high cirrus clouds, actually trap heat and can make things warmer.
Oh, I see. So it's like a balancing act between different types of clouds, huh? What if scientists found out about how cloud cover has been changing?
Well, research shows there's been a pretty big drop in these low-altitude clouds over the last 10 years, especially over the oceans. And that means less sunlight is being bounced back into space. So, you know what they call Earth's reflectivity? Earth's albedo.
Or albedo, right.
Exactly.
So less reflectivity means a darker Earth, which means more heat is absorbed. Got it. So what's causing this decrease in clouds?
Well, scientists are looking into a couple of things. One idea is that it might be because of less air pollution. It sounds weird, but some pollutants can actually help clouds form. So as we clean up the air, which is great for our health, we might accidentally be reducing those low-hanging clouds.
That is kind of catch-22. Cleaning up the air is good, but it might make the planet warmer. Are there any other explanations for this shrinking cloud cover?
Another possibility is that it's a feedback loop triggered by rising temperatures. Think about it, as the planet heats up, it can throw off the balance of moisture and temperature in the atmosphere. And that can mess with how clouds form and how stable they are. So it's possible that warming is causing fewer low-altitude clouds, which then makes the warming even worse.
So it's like a vicious cycle.
Exactly.
This whole cloud cover thing is just one part of a much bigger, more complicated picture. What else could be speeding up global warming?
Well, there's this thought-provoking idea, although a bit controversial, from James Hansen. You might have heard of him. He's a climate scientist who's been warning about global warming for decades. He's saying that global warming is actually sped up by more than 50% in the last 50 years. That's way faster than a lot of climate models predicted.
More than 50% faster. That's a huge jump. Why does he think that's happening?
He thinks we might have underestimated how sensitive the climate is to greenhouse gases, for one thing. And remember that catch-22 with air pollution we talked about? He thinks that plays a big role here, too. You see, reducing aerosol pollution is a good thing for people's health, but it also removes a shield that was kind of hiding some of the warming caused by greenhouse gases.
So it's like we've been accidentally holding back some of the warming, and now that we're cleaning up the air, the full impact of those greenhouse gases is hitting us.
Right, and it's important to say that not everyone agrees with Hansen's views. His recent work, especially his ideas about something called solar radiation modification, has sparked a lot of debate in the scientific community. But there's no doubt he's a really important figure in the climate change field, and he's been pushing us to take this issue seriously for a long time.
Well, it's certainly a lot to think about. Record-breaking cold, record-breaking heat, disappearing clouds, and this idea that global warming is accelerating. It's a lot to process.
Yeah, it's a lot. Maybe we should take a break here and come back to this later. We can talk about what all this means for the planet's future.
Yeah, that's a good idea. Let's take a pause.
So are we ready to jump back into those crazy weather events from January?
Absolutely. We were just getting to James Hansen's work and his idea about this pretty radical solution, solar radiation modification. It sounds kind of like, something out of science fiction.
Yeah, it does sound a bit futuristic, but basically SRM is about intentionally reflecting a little bit of sunlight back into space to counter all the warming from greenhouse gases. It's like creating a giant sunshade for the planet to cool things down.
So we'd be dimming the sun on purpose. How would we even do that?
Well, one way people are talking about is injecting these tiny reflective particles called aerosols into the stratosphere. Those particles would then scatter sunlight away from Earth, so less solar energy hits the surface.
It almost sounds like we'd be trying to copy what happens after a big volcanic eruption. Didn't Mount Pinatubo cool the planet when it erupted back in '91?
Exactly. That eruption spewed tons of sulfur dioxide into the stratosphere, and that actually caused global temperatures to drop by like ½ degree Celsius for a couple of years. SRM is kind of trying to do the same thing, but in a more controlled and long-term way.
It seems almost too easy, like a quick fix for a really complicated problem, but I bet there are some big risks involved. And it probably raises some ethical questions, too.
Oh yeah, you're definitely right to be cautious. Messing with Earth's climate system, even if we mean well, could have some unintended consequences, and they could be pretty bad. Some scientists are worried that SRM could disrupt weather patterns in different regions, change rainfall, maybe even hurt the ozone layer. And then there are the ethical questions, like who gets to decide how much to cool the planet, and what should the ideal temperature even be? This is a global issue, so everyone needs to work together and be really careful.
Yeah, there's so many things to consider. It makes you wonder if climate change is already so bad that we have to try these risky solutions.
Well, that's the big question, isn't it? Hansen, in his paper, argues that just cutting emissions might not be enough to avoid the worst effects of climate change. He sees SRM as a last resort, like buying us some time to figure out a more sustainable way to live.
It's definitely a lot to think about. But having these conversations, even if they're tough, is super important. We have to understand the pros and cons of all the options we have.
Absolutely, and we can't forget that SRM, even if it works, isn't a replacement for reducing greenhouse gases. It's just one possible tool, but the most important thing is still to get off fossil fuels and move to cleaner energy.
I totally agree. There's no easy answer or quick fix here. But let's get back to January 2025 for a minute. We talked about the record cold in the U.S., the global heat wave, and this whole thing with clouds disappearing. And all of this happened during a La Niña year, which should have cooled things down, right?
Yeah, that's a crucial point. La Niña usually makes things cooler because the sea surface temperatures in the Pacific are colder than normal. But as we saw, January 2025 didn't follow the usual pattern.
So is La Niña losing its cooling power? What does that mean for the future? Are we going to keep getting hotter?
A lot of climate scientists are wondering the same thing. It's possible that all these warming factors we talked about, like more greenhouse gases and fewer clouds, are starting to overpower La Niña's cooling effect. And if that keeps happening, well, it means that La Niña years might not cool the planet down as much as they used to.
That's a scary thought. It's like even when nature is trying to help us out, we're still getting hotter. So what happens when we go back to an El Niño, which usually makes things warmer.
Well, El Niño is the opposite of La Niña, right? The Pacific Ocean gets warmer than usual, and that tends to boost global warming. So if we get an El Niño while all these other warming factors are still going strong, we could see some really crazy temperature spikes.
It's a pretty daunting picture. It shows just how interconnected all these climate factors are and how things can change in ways we don't expect.
It is, and it's especially worrying because Earth's systems are getting thrown out of whack at a speed we've never seen before. All these changes, the crazy weather, rising sea levels, it all shows just how urgent this climate change problem is.
It's a wake-up call for sure. Climate change isn't something that's going to happen in the future. It's happening now, and the decisions we make over the next few years will have a huge impact. But it's important to remember that we're not powerless.
Exactly. We have the knowledge, the tech, and we can make a difference if we work together. But we need a change in how we think. We need to realize our actions have consequences, and we need to commit to a future that's more sustainable.
It's a shared responsibility, and the first step is to understand the science, talk about it, and demand action from our leaders. But it's also about the choices we make every day. Every little thing we do can help.
That's exactly right. Whether it's shrinking our carbon footprint, pushing for better policies, or supporting businesses that care about the environment, we all have a part to play.
We're all in this together, and we need to act fast and with purpose. But where do we go from here? What are some concrete steps people can take to make a real difference?
That's a great question, and a lot of people are wondering the same thing. The good news is that there are plenty of things you can do, like in your everyday life and also as a citizen, to help build a more sustainable future.
Okay, so let's break that down a little. What are some things people can do to, reduce their impact on the environment? What are some practical steps?
Well, first off, we can all take a look at how much energy we use. Simple stuff like, switching to those energy-efficient appliances, using LED light bulbs, and just paying attention to how much we're heating and cooling our homes can actually make a difference. And for getting around, choosing public transport, biking, walking, or even carpooling when you can really cut down on your carbon footprint.
Those are great tips for everyday life. But what about, going beyond individual choices? How can people have a bigger impact?
That's where being an active and informed citizen comes in. Support policies and initiatives that promote things like renewable energy, sustainable agriculture, and responsible land management. Talk to your elected officials, make your voice heard, and push for change at a bigger level.
It's good to remember that we have a voice and can actually influence those decisions. But sometimes it's easy to feel overwhelmed by this whole climate crisis. What advice would you give to people who are dealing with, eco-anxiety?
It's totally normal to feel overwhelmed, especially with all the news about climate change bombarding us all the time. It's important to acknowledge those feelings and maybe even talk to friends, family, or a therapist if you need to. But I think it's also really important to focus on the things you can actually control. Turn that anxiety into action. Find ways to get involved in your community, connect with people who care about the same things, and work towards solutions.
Yeah, turning anxiety into action, that's a good way to put it. Are there any resources or organizations you'd recommend for people who want to get more involved in climate action?
Oh, there are tons of great organizations out there doing amazing work on climate change. Groups like the Sierra Club, 350.org, the Sunrise Movement, they're all fighting for climate justice and policy change. And locally, you can always check out environmental groups or community organizations in your area that are working on sustainability projects.
It's inspiring to see so many people and groups dedicated to finding solutions. But we've covered a lot of ground today, from those wild weather events to the complexities of climate science and the potential for both tech solution and individual action. Is there anything else you'd like to emphasize for our listeners as they keep learning about climate change? What's important to keep in mind?
I think the biggest thing to remember is that we're not alone in this. Climate change is a global challenge, and it needs a global response. Connect with other people, share what you know, support initiatives you believe in, and don't underestimate what we can achieve together. We can create a future that's more sustainable and resilient, but we have to work together, stay informed, and never lose hope.
Well said. This has been a really insightful conversation. But like with all our Meteorology Matters episodes, I always end up with even more questions and a desire to learn more. It just shows that learning is a journey, especially when it comes to something as complex and constantly changing as climate change.
And that's a good thing. Curiosity and a willingness to learn are crucial for tackling the challenges ahead.
So to our listeners, we encourage you to stay curious, keep learning, and find ways to get part of the conversation on climate change. Every little bit helps. And if you're interested in diving deeper into the world of weather and climate, be sure to follow meteorologist Rob Jones. You can find him on Instagram Meteorologist, on TikTok TV Meteorologist, and on YouTube Rob Jones Hurricane, where you can also find the Meteorology Matters podcast playlist.
It's been great chatting with you about these important issues.
Thanks for joining us on this journey of exploration. Until next time, stay curious, stay engaged, and stay hopeful.